specific latent heat, the symbol is L. Specific latent heat is the energy E needs to change the state of a substance of mass 1 kg without the temperature change. If we say specific latent heat of fusion, which is LF, specific latent heat of fusion is the energy needed to change the state of a substance of mass 1 kg from solid state to liquid state. Okay, at the point we say at its melting point. I repeat, if we say specific latent heat of fusion, LF, which is the energy needed to change the state of a substance of mass 1 kg from solid state to liquid state at its melting point. What if we now say the specific latent heat of vaporization? The symbol is LV. What does it mean? Specific latent heat of vaporization, LV, is the energy needed to change the state of a substance. In this case, it's from liquid state to vapor state of mass 1 kg at its boiling point. I repeat, specific latent heat of vaporization, LV, is the energy needed to change the state of a substance of mass 1 kg from liquid to vapor at its melting point, at its boiling point. Take for an example, the specific latent heat of fusion of ice, LF, is equal to 3.34 times 10 to the power 5 joule per kg, which means that we need 3.34 times 10 to the power 5 joules of energy to change the state of 1 kg of ice from solid state to liquid state at its melting point, which is 0 degrees Celsius. Next, the specific latent heat of vaporization of water, which is LV, is equal to 2.26 times 10 to the power 6 joule per kg, which means that this amount of energy, 2.26 times 10 to the power 6 joules of energy, is needed to vaporize 1 kg water at its boiling point 100 degrees Celsius to become 1 kg of steam at 100 degrees Celsius, which is also equal to this boiling point. From the table below, LF of water is 3.34 times 10 to the power 5 joule per kg. If we want to melt 1 kg of water at its melting point, the energy required is 3.34 times 10 to the power 5 joules. Okay? For the same medium, water, if we want to change 2 kg of water from ice to water at 0 degrees Celsius, the energy required would be 2 times 3.34 times 10 to the power 5 joules. What happened if we want to change the state of m kg of water from ice to water at 0 degrees Celsius? Then the energy required will of course be m times 3.34 times 10 to the power 5. Okay? Now, if we want to melt a substance we call X with specific latent heat of fusion, LF, from solid state to liquid state at its melting point, and the mass of the body is m, then the energy required would be m times LF, which is equal to m LF. This is the energy required to change the state from solid to liquid without change in temperature. And this is the energy, E2, in the previous pages. Similarly, the specific latent heat of vaporization of water is 2.26 times 10 to the power 6 joule per kg. If now we want to change m kg of water from liquid state to steam, which is vapor state, at its melting point, then the energy needed would be E equal to mass of water times LV, which is the specific latent heat of vaporization of water, which is similar to E times LF of water. And in this case, the energy needed would be m times 2.26 times 10 to the power 6 joules. What if now we have a substance Y which has a specific latent heat of vaporization LV? If we want to change m kg of the substance from its liquid state to its vapor state at its boiling point, then the energy needed would be m times LV, which is m LV. And the energy needed, we call it E4. This is the energy which we are discussing in the previous page.